During this period, carbon dioxide levels steadily declined. Scientists deduced that the temperature underwent a chilling transformation once the CO2 levels dipped below a critical threshold. This, in turn, spawned the formation of vast ice sheets and glaciers, ultimately encasing the entire continent in a frozen embrace. Thus, Antarctica's frozen grandeur holds clues to its past and unlocks Earth's evolution mysteries. But despite the appealing nature of the first theory, it lacked substantial evidence. Consequently, scientists devised a second theory proposing that the continent froze due to dramatic changes in ocean currents. This theory suggested that around 35 million years ago, the Drake Passage, connecting the southern tip of South America to Antarctica, underwent a sudden deepening. This deepening triggered a complete reorganization of ocean circulation, forming the significant Antarctic Circumpolar Current. This newly formed current acted as a formidable water barrier, effectively blocking warmer and less salty waters from the Central Pacific and North Atlantic from flowing southwards towards Antarctica. Consequently, this isolation caused a decrease in temperature, resulting in the continent's freezing. Although plausible individually, these two theories were eventually linked by visionaries like Musk and other scientists, who believed that this provided the best explanation for the continent's transformation. According to their findings, the deepening of the Drake Passage altered ocean circulation patterns, resembling those observed in the Gulf Stream. This shift directed warm waters northwards and caused a change in the ocean currents. As a result, rainfall increased significantly. Continuous rainfall plays a crucial role in reducing the carbon dioxide content in the atmosphere through a process known as silicate weathering. During silicate weathering, rainfall eroded rocks containing silicate, trapping carbon dioxide in limestone formations. The substantial drop in CO2 levels became a catalyst for glaciation, turning the continent into a massive ice mass. This compelling explanation aligns with recent climate change observations and oceanic circulation patterns. However, this time, the effects are reversing the events that took place 35 million years ago. In the latter part of 2022, both polar regions of the Earth experienced simultaneous and unexpected heat waves. Antarctica's average temperature soared to an unprecedented 8.6 degrees Fahrenheit or 4.8 degrees Celsius, while the Arctic region witnessed a 6 degree Fahrenheit or 3.3 degrees Celsius increase above normal. Additionally, a significant discovery regarding the ozone layer came to light on World Ozone Day in 2022. Scientists have since discovered that the Antarctic ozone layer had depleted, creating a massive hole that's larger than the entire United States. Geologists and other experts alike have therefore begun to sound the warning bells that the depletion of the ozone layer may contribute to global warming, which, in turn, would cause the complete melting of the ice in Antarctica. And unfortunately, an alarming occurrence has already begun to unfold. Recently, scientists made a startling discovery. The colossal A76A iceberg, the largest known iceberg in the world, has broken free from its Antarctic shelf and embarked on a drifting journey towards the treacherous Drake Passage. This immense ice formation spans approximately 84 miles in length and 16 miles in width. As it traverses its path, this icy behemoth is destined to gradually melt away, posing a grave risk of elevated sea levels that could potentially lead to catastrophic flooding. A recent study has likewise brought to light the astonishing retreat of another ancient ice sheet, melting away at a mind-boggling speed of 2,000 feet every day. This revelation has offered scientists valuable insights into the potential rapid melting of ice in Antarctica and its consequences for global sea levels in our warming world. During the final stages of the previous ice age, sections of a colossal ice sheet covering Eurasia astounded experts as they retreated at a rate surpassing 2,000 feet per day, a distance greater than the towering Empire State Building. This unprecedented rate of retreat defies what scientists had previously believed to be the upper limits for ice sheet regression. The discovery carries significant implications for understanding the pace at which ice in Greenland and Antarctica could melt, causing a rise in global sea levels. By closely monitoring the rate at which ice sheets recede, scientists can more accurately gauge their contribution to the rise in global sea levels. Since the 1990s, Antarctica and Greenland have experienced a loss of over 6.4 trillion metric tons of ice, resulting in a rise of at least 17.8 millimeters in global sea levels. Remarkably, these two ice sheets alone account for over one-third of the total increase in sea levels. As the ice sheets retreat towards land, they detach from the seafloor, causing them to float and accelerate their flow. This accelerated flow increases the contribution to the rise in sea levels. Consequently, if air and ocean temperatures surrounding Antarctica were to increase as projected, matching the conditions observed at the end of the previous ice age, researchers warn that the ice could retreat hundreds of feet in a single day, triggering the collapse of contemporary glaciers at a much faster pace than previously anticipated.